Okay, so this video is going to go with section 4, and this will be the last section that relates angles and arcs in terms of their measures. Now, I want to go backwards because and talk about the first ones here, because you'll see as we put this together with these last categories, there's a pattern you can follow that will help in finding missing angles, missing arcs, etc. The first ones we talked about were um, central angles. And here's what we said. If you're given a circle, okay, a central angle has a vertex at the center. And we said the measure of a central angle, it must always equal its intercepted arc. Okay? So if this is n degrees, then so is this. These must be the same. And I repeat, when the vertex is at the center, this is always true. Okay, when the vertex is at the center, this is always true. Now, the next one we talked about was an inscribed angle. An inscribed angle, on the other hand, has a vertex that is on the circle. So here's my vertex. Stretch out, here's a chord. Here's a chord. Okay, if this is x, okay, then this will always be twice that amount. So the arc is always twice the angle is always half the arc. Okay, so the vertex here is on the circle. Now, what we want to do today is we want to add the other possible categories based upon the location of the vertex. Okay, and we're going to do this by interacting some different figures. Okay, so here's another one that they will talk about here in section 4. This one had two chords. So here is a circle. Here's a vertex. Okay, this is a tangent, and this is a chord. Okay, so it looks a little bit like this. Okay, because the vertex is still on the circle, the rule is the same. Okay, if this is x, then this from here all the way down will always be 2x. Okay, if this is y, then this will be 2y. Okay, so the vertex is on the circle, so the angle is half the arc, or the arc is twice the angle. Okay, so the vertex on the circle. Now, in the last two categories, again, moving the vertex around here, here is a circle. This time I'm going to take two chords and intersect them. Okay, so here is angle 1. Okay, and this over here is also the same measure. Maybe I better label that n. So here's n degrees. This is n degrees. Okay, because they're vertical, they must be the same. But if you look, this time the vertex is inside the circle, but not at the center. If it's at the center, we go back to that very first rule. Okay, and this n cuts off this arc. This n cuts off this arc. Okay, so here's what the formula says. To find the measure of the angle n, we take the average of the two arcs. 1/2 of arc 1 plus arc 2. Okay? So again, note the location of the vertex. Notice how we had to adapt. Now that there's more arcs available that associated with those angles, we must use each one. Okay? And the last one that we talk about, we've talked about the vertex is at the center, on the circle, inside the circle. So the last one is outside the circle. And there's a couple different ways that that could occur. So here's my vertex here. And here's my first way. If I take two secant lines and draw from a point outside of a circle, here's angle X, here's arc 1, here's arc 2. Okay, when the vertex is outside the circle, we take 1/2 the difference of the arcs. So X equals 1/2. Now, you got to go out to the biggest one first, otherwise it'll be negative. So I'm going to go arc 2 minus arc 1. Okay, so inside the circle, you add them and divide by 2. The vertex is outside the circle, you subtract them and divide by 2. Now, again, this is when they were formed by two secants. The other option would be if you were to form that outside angle by using a secant and a tangent. Okay, again, same situation still holds true. You still have angle X, you still have arc 2 and arc 1, and because the vertex is outside the circle, X is still 1/2 the difference of the two arcs. Arc 2 minus arc 1. Okay? So all of these would be good examples to write down in your notes so that, especially as we put it all together on the test. So again, you take a good look, decide where the vertex is, you'll know exactly what formula to use. Okay, so the last thing I want to show you is a special version of this last rule. What if I have two tangents? Okay, and I know that here's a tangent. Okay, here's a tangent. Okay, let's say that this is, I'm trying to find out what X is, and all I know is this is 260 degrees. Okay, now that would represent your arc 2, but I don't know arc 1 and I don't know the angle. Okay, here's the thing to remember is that when you're dealing with two tangent segments, the sum of the two arcs, arc 1 and arc 2, must be 360 degrees, must be the entire circle. So if this is 260, then this has to be 100. Okay, so then I can say, well, then X must equal 1/2 of 260 minus 100, which is 160, and half of 160 means that X is an 80-degree angle. Okay, so they're going to break them up into groups here, the questions on the reteaching part, and then they'll mix them up a little bit more as you go along. But let's look at some examples of what they're asking you to do on these problems. So on the first page, you have questions 1, 2, and 3. If you look at number 3. So on number 3, I can do this right on the sheet. That might be work. Okay, they don't give you a whole lot. Everything is in terms of variables here. So okay, so here's the first thing I'm going to do. Okay, notice that you have against this tangent line, you have angle x, and you have angle 2x. Okay, those two angles, when you put them together, form a straight angle. And so we know a straight angle measures 180 degrees, so we can say that 2x plus x equals 180. So 3x equals 180. Dividing by 3, that means that x equals 60. Okay, so I can plug that back in. This is 60 degrees, and this is 120 degrees. Okay, now go back to your rules. Okay, we know that the vertex is on the circle, so the angle is half of the arc. So to find the missing arc, that means I just need to take the angles and double them. So z becomes 120, and y becomes 240. And you're done. Okay? So you can tie in some other rules there as well. You got a 90-degree angle here on number 2. You have x and y that are going to add to 180 there as well. Okay, and you're given an arc. Okay, so that information can all be used to find x's and y's, etc. Okay, next page. Moving on to the next formula here. On 4, 5, and 6, the vertex is inside the circle. Okay, but not at the center. So this is where inside we're going to take 1/2 the sum of the arcs. So look at number 6. Okay, so here's the angle. Here's arc 1 and arc 2. I know that 45 has to equal, the angle has to equal 1/2 2x plus x, the sum of the two arcs. So add them up and you get 3x. So 45 equals 1/2 of 3x. I'm going to multiply both sides by 2, and that gets rid of the 1/2 for me. So 90 equals 3x. And then I divide both sides by 3. So x equals 30. And that's all they want. They want the measure of angle x, and I found it. I don't need to do any more than that. But again, follow the formula. Okay? The angle equals 1/2 arc 1 plus arc 2. If you follow that format for those 3 problems, okay, you'll be good. And again, they show you an example problem. Okay, study the examples, and you can use those as well. On the bottom of the page, where you have 7, 8, and 9, again, note the location of the vertex of the angle. They've moved it outside. Outside means we subtract. So I'm going to, in this case, the angle equals 1/2 the outside angle, 8x, minus the inner angle, 2x. So 60 equals 1/2 of 6x. Multiply both sides by 2. So 120 equals 6x. And again, divide by 6, so x equals 20. Okay? So all of those were grouped together nicely. That'll make those a little bit easier. Okay? On practice A, which is the other part of this assignment. Here they have been mixed up. Okay, so again, the first question you should ask yourself, where is the vertex at? Okay, so on question number 1, it's outside. Here's your vertex up here. Sorry. So we're trying to find the measure of angle 1. Okay. Here is your vertex. So I'm going to do a subtraction. And so I know the measure of angle 1 equals 1/2 of, now again, I've got two tangents here. So if the outer arc is 270, remember we said they had to add to 360, that means the inner arc is 90. 270 minus 90 is 180, and half of 180 means that the measure of angle 1 equals 90 degrees. Okay, I know I kind of wrote it on top there, but kind of running out of room. Okay, if you need to, you got the back side you can use to do some of your work as well. Okay, number 6 is one that's a little bit trickier than the other examples I gave you, because notice the arcs that are given and notice the angle that's given. Okay, the vertex is inside the circle, which means we take half the sum, but it's the wrong angle. Okay, so here's what I'm going to do with this problem. I'm going to come in here and label this angle 2. Okay, now what I'm going to do is I'm going to set up and solve for angle 2. Okay, so the measure of angle 2 is going to equal 1/2 of 97 plus 115. So if I add those, looks like 212. Okay, and when I take 1/2 of 212, I get 106. So the measure of angle 2 equals 106. Now, 1 and 2 must add to 180 because they form a straight line, a straight angle. Okay, so if I take 106 and subtract from 180, it means that the measure of angle 1 has to equal 74. Okay, so they're going to, on some of these, they're going to add a little twist. Okay, just remember your rules and you should be able to find the extra pieces you need. Okay, on number 7, also a little twist. Okay, the vertex is outside the circle. So when it's outside, I need the 2 intercepted arcs. The problem is I'm only given one of them. Okay, but here's what I can do. I know that all 3, again, must add to 360. So if you take 360 and 360 minus 134 minus 12, okay, this has to be 214 degrees. So now I can say, based on that, that the measure of angle 1 equals 1/2 the outer arc, which is 214, minus the inner arc, which is 134. Okay. 10 through 12, they want you to set up a formula, okay, but they don't want you to solve it. You don't need to, okay? So, and I would accept different versions here, but like on number 12, I'm given that this is 96, okay, but I need over here. So if this is 96, then on the other side of that is 84, because they form a straight angle. And because the vertex is on the circle, we know that x equals 1/2 of 84. 1/2 the angle. Excuse me, twice. I'm sorry. I'm finding that. So at 2 times. Yeah, x equals 2 times 84. Okay, so sorry. So if you write out a formula like that, if you even backed up and said, well, x equals 2 times 180 minus 96, that's okay too. That's how we found 84, is by subtracting. But you take the angle and double it to find the arc. Okay, so that's your being asked to do there. And again, on a 13 and 14, again, they don't want to know the answers because you don't have enough information. Okay, what they do want to know is how do the 3 angles relate? How do the 3 angle measures relate? Put them in order of increasing increment measure. So in other words, which one will be the smallest? Okay, then the larger, then the largest. And the thing to remember with all of these, and hopefully you found this out as we were working with these, is that the farther you get, the vertex gets away from the arc, the smaller the angle. It's like taking a rubber band and starting it from 2 points. The further you pull it away, the smaller the angle is going to get. Okay? So recognizing that, you should be able to put 1, 2, and 3 in order. Okay? Again, so I want them in order of increasing measure from smallest to largest. Okay? So that should help you out a little bit with those. Again, my advice again is take a piece of notebook paper and write down all those rules that I gave you at the beginning of this, and then you have that sheet as you go through. When you do the test questions, it'll make that so much easier. Where's the vertex at? At the center, on the circle, inside the circle, outside the circle, and then use the appropriate formula from there. Okay, so email me if you have questions.